Hello, welcome to today's webinar from Element 14 in collaboration with FTDI Chip. Today's presentation, FTDI will be introducing the EVE 2, the next generation. Presenting today we have from FTDI Chip, Gordon Lunn and Steven van der Wolf. If you have any questions for either of our presenters throughout the webinar, please use the Q&A function found in the drop-down menu of the green taskbar of the WebEx application. If you have any technical issues during the presentation, please chat Premier Farnell webinars directly by using the chat function. A recording of this presentation will be made available on the event page in which you registered from on element14.com. So without further ado, I'll turn it over to our first presenter, Steven. Take us away.
Hello, and thank you for that. Welcome to this FTDI Chip webinar brought to you by our distribution partner, Farnell Element 14. My name is Steven van der Wolf, and I am the European Sales Manager for FTDI based in Glasgow. The main speaker today will be Gordon Lunn, who is our Global Technical Marketing Manager, also based in Glasgow. Now, I'm sure you're aware that FTDI Chip was established over 20 years ago in Scotland's largest city as a USB connectivity company. Yes, we have a full range of USB solutions to fit any application, but FTDI Chip does so much more in addition, as we aim to bridge multiple technologies with USB to RS232, 422 and 485 cables, super bridging MCU families, and display systems offering complete solutions including free software and drivers. If we go to the next page, Gordon, I just want to carry on that one, yeah? No? Previous? Yeah, thank you. So FTDI has got an exciting year past us where we introduced quite a lot of new products, and they can be seen on the next page. We have released a Super Speed USB 3.0, the FT6OX family, as well as our first 32-bit Super Bridge MCU family, the FT90X family. More on that you can find on our website. But today we're going to talk about our embedded video engine solutions, also known as EVE, for which we have announced production release on the 30th of September for IC and development modules, all listed on the Farnell website. However, I must say that due to overwhelming customer interest upon our recent production release, Farnell is currently taking orders for IC and modules, but is currently awaiting delivery of inventory from FTDI Chip to satisfy those orders. These will be in-house within Farnell within the week, so you can already place orders online today and start your development for your next design using our EVE technology very soon. Gordon will outline the offering and further extension to the modules being made by the end of January next year, and more information on this can be found on our website, ftdichip.com, and you can also follow us on Twitter and Facebook pages. So now I'll hand over to Gordon for the main session.
Okay, thank you, Steven, and welcome everybody to the webinar. So today obviously is all about EVE and EVE 2, the second generation. But what I'd like to do with you all is take you through what EVE is, explaining the initial offering and how we have extended it to make EVE 2. So EVE is essentially the embedded video engine solution. We have an advanced object-oriented approach to rendering graphics through line rendering, which means we reduce frame buffering and bill of material costs in your final solution, but we also add touch control for either capacitive or resistive displays, and we have integrated audio output. This means we call it a 3-in-1 solution, which is ideal for HMI bridge solutions. So before we look at the technicalities of the chip, I'd just like to highlight some of the key application areas where we as FTDI are seeing a lot of interest and might be of interest to you. My personal favourite is the industrial HMI. Current technology, thermal chambers, car diagnostic systems, they may have monochrome systems or 7-segment display solutions. These types of applications are now ripe for going to the next generation with a full colour TFT solution, replacing buttons, you know, your standard mechanical buttons, with a touch screen solution. So industrial HMI is very key for us, as is home automation, which is very much Internet of Things technology. If you imagine you want a smart light switch monitoring heating and lighting controls in your home or office, we have the ideal display and control solution for that. You'll also find, when we come to later slides, surveillance and security. We not only render graphics, but we actually play back video. So we can actually create an in-house security video or smart doorbell type of solution with the EVE IC. So moving on, if we look at the roadmap of development, we first introduced the original FT800 device, a 48-pin QFN SPI peripheral to your main system controller, which offered audio, touch and a resistive display. We then moved during 2014 to add capacitive display support, which is really just for the touch technology was changed, and we have since then introduced a microcontroller which will enable you to control our SPI solution for graphics, as well as EVE 2, which is the 810 and 811 series. There are actually more chips in the series which we will talk about in a further slide. But let's look at graphics technology in general. A traditional solution will start with quite probably a high-end microcontroller, a 32-bit solution, probably ARM, but it's a very large and powerful device, probably running a real-time operating system. There may be separate components for touch, for audio, and almost certainly a frame buffer. Your typical architecture will store a full frame of display in fast memory before outputting it to the display panel. This is an expensive component, as can be the associated RAM and flash for your 32-bit microcontroller. FTDI with EVE have been able to simplify this block diagram. You can see there are much fewer blocks on this slide here. The 81X has integrated the audio, the touch and the display. We have an interface to a system microcontroller, which may be either SPI or, with the EVE 2 generation, Quad SPI, which we use the Quad SPI mostly for the video applications, as it allows faster transfer of data. But the key point is, you can now realize very feature-rich display solutions with a very low-cost MCU. 8-bit PICs, 8-bit 8051s, Arduino processors are perfectly adequate to have a full-color TFT with touch and audio HMI solutions. You'll also see on this slide, we are now supporting display resolutions up to 800 by 600 pixels. This takes us from a sweet spot of 3.5-inch displays up to 7-inch displays. That's the sort of main window of opportunity and the most common displays, but we can actually handle slightly larger displays with this resolution. You'll also find our output is the red, green and blue data signals for the display, and we can offer you full 24-bit color with EVE 2. With EVE Generation 1, we gave you 18-bit color and color dither. I'll come on to these algorithms later. But the key thing from this slide is it's a 3-in-1 chip, reducing your bill of material both in terms of cost and in terms of board space. So if we take a look inside the chip, how are we achieving this 3-in-1 functionality? Well, on the left-hand side, top corner, we have our MCU interface. Because remember, one of the key benefits to EVE is the flexibility of this solution. We are not locking you in to using a dedicated processor with inbuilt graphics. We are a very simple SPI or QSPI peripheral. This allows us to work with many microcontrollers, giving us great flexibility for new designs and update to existing designs. On the right hand side is our graphics control block. I talked about the colour data on the previous slide, but we also have controllable timing signals for the video, so the horizontal sync, the vertical sync and the pixel clock. These are all controllable timing parameters which enables this one chip to function with different resolution and different screen size displays. Another key feature is the backlight control. We can essentially make the backlight be dim or bright, which is good for daylight or nighttime operation or power saving operation. Our audio output is a very simple PWM output. It's one wire, gives you mono audio. We have integrated chirps, beeps and tones, so you can make like a telephone keypad or a ringtone from this audio. Or with the audio engine we can also play back pre-recorded audio. On the touch side of things, I've said we've got resistive touch and capacitive touch control. If it's a resistive display you have, data comes back in X and Y values, and if it's a capacitive display you have, capacitive displays are constructed with what's called a capacitive touch control module, and these typically have an I2C interface, and we provide the I2C signalling to talk to that module on the display. The central column of our block diagram is really the guts of the chip. Obviously there are some key registers. These registers, for example, would control the timing of these timing signals. We have some RAM. In the RAM we store objects. We've talked about EVE being an object-oriented solution. An object could be a bitmap, it could be a font file, it could be an audio file. On EVE Generation 1 we gave you 256K bytes of RAM. With EVE Generation 2 we have boosted this to 1 megabyte of onboard storage for all your bitmaps and files that you wish to display. The ROM that we have allows us to have dedicated widgets, which again I will talk about in a future slide, as well as fonts, embedded fonts that we can play. This is also where we store our ringtones, our chirps, our beeps. And the graphics engine, audio and touch engine are really the parts of the chip which process the data to be output. So, it's not obviously just about cost, it's also about a quality of display. And how does FTDI and EVE achieve the quality? Well, the first thing is, with our object-oriented approach and rendering the object line by line as opposed to a frame grabbing version, we can actually output data to 1/16 of a pixel resolution. It's not actually 1/16 of a pixel. We do a little algorithm where we take blocks of 16 and work out which one should be displayed. Anti-aliasing is another key feature. If you have a diagonal line on a display, it can sometimes look like a staircase. It's a jagged line. Anti-aliasing is a feature that smooths that out. We also offer alpha blending and masking algorithms. These are creating shadows and 3D effects. We can do overlay. So maybe you have a television at home where you can get an on-screen electronic programmer's guide and you can see the TV while the channel list is also being displayed. That's where alpha blending would come in with overlays. The color dither, I mentioned it earlier. When we have solutions that have 18-bit color, which means we've got 6 bits for the red, the green and the blue, with color dither we can process to get closer to full 24-bit color. So this gives you improvement of the half-tone appearance on the packages that don't offer 24-bit red, green, blue coloring. Because we have an object-oriented approach and a very simple programming method, everything goes on a display list, and we have 8K of RAM to store your display list. What you would put on a display list is in essence what you want to display, where you want to display, the colour and the size of what you wish to display. With those 4 elements, you can build up a very complex image very quickly. Now, some of these elements that are on here, such as the anti-aliasing and alpha blending, it's key to note we have had feedback from customers who are using the more expensive integrated ICs. They might not necessarily include these algorithms in those alternative solutions. So again, when you're comparing Eve with alternative solutions, look out for these little extra features that can potentially improve the quality of the end product you are displaying. Now, with regards to the display list, here's a little block diagram of the data paths. We have at the top of this slide GRAM. This is the object RAM. This is where your bitmaps would be stored and collected from the graphics processing unit for display. We then have 2 paths for the display list. Down the middle to a ping pong buffer. Now we call it ping pong because one is the buffer that you are writing to, and the other buffer is the buffer that's being displayed or processed. So you just simply write to a buffer and swap it. That's where the ping pong comes in. We then have a second path called a FIFO path, which allows us to put more complex instructions onto the display list. If I was going to use a display list that was using widgets, which is essentially a zip file of primitive commands, I would go through the FIFO path, which would extract and expand the widget into primitive commands to go onto the display list. So anybody developing with Eve, I would always recommend to take this path as it is more powerful. This path is ideal for simple lines, circles, etc. But if you want to start drawing clocks and buttons, we recommend this path. Couple of things that I would like to highlight. Obviously I mentioned the object RAM is a fixed size. In Eve Generation 1 you have 256 KB, and with Eve Generation 2 you have 1 MB. So obviously if you were to overrun that maximum size, you would get a corrupted image or audio feedback. So bear in mind that is the maximum size. And this is the area for storing your bitmaps, your own dedicated fonts, and for storing any audio files you wish to have as playback. The circular buffer here, which is what the FIFO is, so if I go back, this here has a fixed size also, 4 KB in size. You must always remember when it goes from 4K to make sure your pointer in your software resets back to 0, and then it clocks round again. You must also try to keep the read command pointer and the write command pointer in alignment. So when you write to this location, this circular buffer, the address will keep adding up, and then when you do a swap command in your display list, this read pointer will start to follow to catch up to where the write pointer finished. And when the read and the write are in alignment, you then have completed the full display list and you can start a new list. You should always start the next list from where the previous list ended. Now, it's not just about the display. HMI is also about audio and touch. With the touch, as I said, we can offer you support for resistive or capacitive touch screens. The reasoning behind selecting resistive or capacitive? Well, a resistive display will support a single touch point. A capacitive touch can support multiple touch points, which enables gesturing. So for example, on a capacitive display, if you had two fingers pinching in and out, you could create a zoom function. That would not be possible in a resistive display. We also have, and it's very important, this last point, the tagging point. Normally with a resistive display or even a capacitive display, you get back XY coordinates of where you have touched. A displayed object is actually an area. A touch point is a point. Somebody somewhere has to do the algorithm to calculate what area that point is situated in. We do that on board with the EVE2 chip. We have taken processing away from your system microcontroller and put the effort into EVE, which is part of how we can work with the low-end 8-bit micros. So every object that we display, so an entire area, is given a tag value. And if you touch within that area, your microcontroller will receive a tag number. Your microcontroller code will then have a list that says, if tag value equals a number, perform function whatever that number was. Much simpler than asking the microcontroller to calculate if that touch point was in a specific area. You can also see we've got additional filtering on our touch, so we can adjust the sensitivity when someone is pressing the screen. On the audio side of things, we've got the 64 inbuilt tones, as I say, bells, chirps and beeps, and we've also got the ability to play back audio from 3 different encoded formats, whether that be the PCM, ADPCM or MuLaw encoding formats. Very flexible. When you might want your own audio message would be, for example, in an elevator. When you arrive at a floor, the audio might say floor 1, floor 2. A little bit more information than just a simple beep or bell. And here are the data paths through the chip for the audio and for the touch. Very much simpler, and what I want to try and get across from this is to control the audio, it's simply a case of writing to a few registers. If you're using the inbuilt tones, the registers simply select the tone, select the volume, start and stop. If you are using your own audio file, the audio file would be stored in here for playback through the processing unit. And as we talked about the touch, again, we just have registers to read the tag values, or if you prefer to read the raw X and Y coordinates, you have that option also. Now, this slide is trying to explain a display list. I've tried to say before, we don't do frame grabbing, we effectively draw the image on the fly through a display list by adding simple components. Every display list will start with a clear, and this display list is going to draw a red circle on a black screen. So we've selected the colour, and this is going to be the colour red, and we've set the size of our circle, and then we've said we want to draw a circle, and we've given it a location. We've then ended the circle instruction, and all display lists are terminated with the display command. To make the display change, remember we talked about the ping pong buffer, so we have a swap command to swap the buffers. And this is swapping on a frame basis as opposed to a line basis. We always recommend changing a buffer on a frame boundary, as it may result in tearing if you do on a line boundary halfway through a screen. But what you can see from this very simple display list is, all I had to say was, what am I drawing, where am I drawing, what's the colour, and what's the size. Very, very simple, and to add more objects, you just effectively repeat this process, what, where, size and colour. To go more advanced, we have inbuilt widgets. Now, this is a basic clock face. You can see there is a large circle at the back 12 circles for the numbers and 3 lines for the hands. We could do that as primitives, but every instruction you send over SPI is 4 bytes. We deliberately pad it to 4 bytes to make the addressing in your microcontroller simpler. So rather than having 16 commands, which is your 13 circles and 3 lines, we simply say clock. So we reduce the amount of SPI traffic, keep the bandwidth on the SPI to a minimum. Eve will understand command clock and essentially unzip it into all the primitives that are draw the circle of a certain size at a certain location with a certain colour. So this is another way that FTDI have tried to simplify creating graphic solutions for the customer. There is obviously a certain amount of customization that you as the customer can do. You can change the colour, you can take away the seconds hand or the minutes hand, you can take away the numbers, change the background, etc. And then moving on to the next stage of a display list, just want to get across the idea of the objects. So I've got a text command at the top, I've got a clock command, I've got a power line strip command, I've got a gradient command for the background colour and the signal colour, and then with the display I essentially take all these objects and add them together to make a composite image, which is in the bottom right hand corner. So we just treat the display as a collection of objects, not a full frame that must be drawn. This also has the benefit that if you want to update a certain portion of the screen, you don't have to grab a whole new frame to redraw it. You can simply edit, let's say the clocks. You could change this clock element of your display list, and then it would just be the clocks that need to be redrawn. So you can reduce the amount of coding that's required to do screen refresh and screen updates. This is just the full code shown in a different format with the end product of the composite image. Now that's the basics of Eve technology, whether it be Eve Generation 1 or Eve Generation 2. Let's have a look at what we have added to extend the family to make it Eve 2. And the first thing we have to look at is a rotation algorithm. This has been the #1 most interesting feature as far as customers have been concerned in terms of the feedback I have received. With Eve Generation 1, if you wanted to rotate between landscape and portrait, you had to rotate each object individually. With the new Eve 2 generation, we have one instruction that sets the orientation up, and you put that at the very first line of your display list. So customers can now have one set of hardware and make multiple products, if you like. Some are landscape, some are portrait. Very simple to do. With Eve Generation 2, we've made it faster. 4 is quite a big number in Eve Generation 2. It's a 4 times faster in many ways. Drawing the pixel clock is now 16 pixels per clock. It was 4. We've gone to quad SPI instead of SPI. There's a 4 as well. JPEG is now a hardware function, JPEG decode, so it's 500 to 1,000 times faster. And also video playback, so there's a dedicated video mode in Eve Generation 2 which allows us to stream video very smoothly, and we've shown demonstrations in the past up to 60 frames per second on a 7-inch display. It's not blocky, it's not jerky, it plays back very smoothly. And then there's some additional loading commands if you have your own fonts that are making life a little bit simpler. So those are functional changes that we have made. And then there are also some physical changes. Eve Generation 1 had a maximum resolution support for 512 by 512 pixels. We are now up to 800 by 600 pixels. This is what has taken our support from 5-inch displays up to 7-inch and beyond. we've extended the RGB interface, the colour pin interface, from 18 bits to 24 bits. We did this because when you go from, for example, a 3.5-inch display to a 7-inch display, it's analogous to going from standard definition to high definition television. You can see more of the blemishes, you can see more of the blocks. So we've added the extra colour to again improve the quality of the end product. I said SPI has been extended to support quad SPI. This allows for faster transfer between MCU and the EVE chip. We've also got some additional GPIO pins which can be used for any features. It may be like a reset pin for something, or to switch something on or off. And there are 4 packages with EVE Generation 2, FT810, 11, 12 and 13. The even numbers, the 810 and the 812, support resistive, and the 811 and 813 support capacitive solutions. With the FT810 and FT811 packages, these are footprint backward compatible with EVE Generation 1. So if you already have an EVE Generation 1 solution, the PCB, you can simply put this chip in its place and you have access, for example, to extra onboard memory and extra, the additional rotation feature. So there might be some features in there that are of interest to you without having to change your PCB. For the 812 and the 813, we had to go to a 56-pin package, and this was done to enable us to output the 24-bit colour on the red, the green and the blue. However, I'm sure you will agree these are still relatively small packages for what you are getting in terms of functionality. Now obviously, with all these extended features, although the footprint is backward compatible in the 810 and 811, we have had to make a few tweaks to the register map and the basic addressing of some of the features. For example, if you look, the object RAM, it was originally 256K, it's now 1 meg, so we have to extend the address range for that area in the chip. So anybody who has developed code for EVE Generation 1, they should refer to our programming guide or our sample code, which has a very simple header file with all these differences coded out for you. This slide is basically a summary of all the packages. The first 2 columns are EVE Generation 1 and the next 4 columns are EVE Generation 2. Very similar across the board. They all have audio out. The memory, as you can see, is different, 1 meg or 256. The interfacing, SPI or SPI and QSPI, and then you select resistive or capacitive. Down the bottom you have your package size. I would let you review this at your leisure rather than go through the detail during this presentation. Now obviously FTDI is a fabless IC design company, but we understand to develop an end product it's always useful to have a development module or an application module to get you started. And with that in mind, FTDI have provided a range of modules. These are available from Farnell, and it all starts with the very simple credit card module. We started with EVE Generation 1 supporting 3.5, 4.3 and 5-inch displays, and you can buy this module with or without the display. It includes the EVE chip, it includes a speaker so you can hear your audio, and it includes a connector to allow you to put any microcontroller into this chip over SPI. There's a connector goes on down here where there's little header pins you can solder on. Taking that to the next level, we put a plastic bezel around it. It makes it a little bit more robust for handling, but it can also, in theory, be used as an end product. You can simply put a cutout in the panel of your end product, this will press fit into the wall of that panel, and again up here you can see the header pins to allow you to connect the microcontroller of your choice. We then also did a third variant where it was a simple USB connector. So we added our FT232H chip onto the board, FTDI's USB to SPI bridge, to allow us to just have USB coming off board. Makes it very simple for you to cable up in an end product. Then moving on from that, we did what is much closer to an end product solution, which we call the Plus module. Again, in 3.5, 4.3 or 5-inch solutions. So extending from the basic module, we added an Atmega processor or an Arduino processor. We also added SD card to allow you to store additional bitmaps and photographs, pictures off chip for use during your display, and a real-time clock was in here also. But perhaps most interesting was the red connections, the two connectors at the top here. These are actually expansion sockets to allow you to add plug-in cards, and this is where EVE starts to become not just a display solution but an HMI, human machine interface. This gave us the window into a wider system. We can connect to Ethernet, to RS-232, RS-485. Typical example might be in a restaurant or a retail situation where you are front of house or at the table in the restaurant, placing your order on a display embedded in the table, and that can be transferred over Ethernet or one of these other interfaces to the kitchen or back of house for your order to be processed and brought to your table. As you can see on this slide, starting at less than £20 from Farnell. Very cheap, very powerful solution. And then with EVE 2, we're not forgetting EVE 2, we will be providing modular solutions for that also. We currently have the VM810, which is based around the credit card style of form factor. We can do it with or without a display module. $30 without, $69 with the display, has an SPI interface and a resistive touch screen. But then more excitingly will be the ME810, 811, 812 and 813 displays. This is where we will be offering up to 7-inch display solutions, both in resistive and capacitive. We'll not only offer SPI, but we can offer quad SPI. We'll do USB variants, and this will allow you access to the EVE 2 chipset and a microcontroller of your choosing. And then finally, we have to look at the tools. So we've given you the silicon, we've given you the development module, we do actually provide libraries and sample code, but we also provide tools to facilitate creating a solution. And the first tool is the screen editor. This tool allows you to drag and drop objects from a toolbox onto the palette in the middle of the screen. You can adjust the properties in a properties window, or you can simply type in a text box window at the bottom of the screen to create a display very quickly. All the objects are included in this tool, and we then allow you to export the code, in this case to either Arduino or GameDuino, which is a third-party product. It's actually writing code from what you have drawn. So you do not need to do any coding, and this will convert your display to C code, so that it can then actually be programmed onto the hardware without anybody knowing anything about software. This tool is ideal for design engineers, hardware engineers, getting started, design proving their designs. But in addition to that, we also have Screen Designer. It looks very similar to Screen Editor, but this is more targeted to graphics designers, the people who are worried about the aesthetics of the final display. It has grid lines for locating your objects very precisely. It allows you to create multiple displays, zoom in, zoom out, group and ungroup objects for moving them around the display. So these are two powerful tools that we offer, not only to make it simpler, but to make it faster to realise your end solution. And if we take now a look at a case study, we've looked at the technology, we've looked at the product offering. Where's FTDI winning business? Well, you may all be aware of smart home technology. In the UK government is very keen that all homes and businesses have smart meters, primarily for electricity, but this could extend to water and gas. There are 26 million homes in the UK. That's 26 million smart meters, and it's highly unlikely that the same meter will be used for gas, electricity and water, so that would be 3 times 26 million smart meters required. We can offer one display to talk to 3 meters, or we could have 3 separate displays, all based around our technology. And this is how FTDI can support you, also in association with supporting Farnell. This business was high volume and extremely cost sensitive. Our line rendering approach reduced the bill of material on the board. The integrated touch and audio reduces the bill of material cost on the board. We can work with lower cost, lower specified MCUs, your 8-bit versus your 32-bit microcontroller. So everything that Eve was offering was bringing the cost down at every step. The project was a very short timeline project. We have a vast array of sample projects for multiple processors, showing multiple features of the chip, using widgets, using primitives, showing how to do keypads, etc. So there was a lot of sample code to get the developers started. With the object-oriented approach, your code is very much simplified, especially when you start using the predefined widgets, so it's less lines of code, less debugging. And then the ability to rotate the display was key for this customer road mapping their future products. They will have one set of hardware that can perhaps operate for different customers. Some of their end customers will want portrait, some will want landscape. One piece of hardware can do it all. And then finally, and perhaps most importantly, just as we are engaging with you today through the webinar, FTDI will visit in association with distribution partners such as Farnell. We have dedicated support personnel here in the UK, the US, Asia. We are a global operation. We can provide support for this and all FTDI products. Now, I've talked about Eve can work with any MCU, and most customers are tied into a microcontroller through past projects. However, FTDI would like to offer a total solution to the customer. We've given you the SPI device, the peripheral chip. We've given you the software examples, the development modules. You do need something to drive it. So I'd like to take a few minutes to introduce our 32-bit microcontroller, which is an option to perhaps talk with Eve if you want a one-stop shop. And this again will be stocked through Farnell. So we have our FT90X series, a 32-bit microcontroller. From an Eve point of view, the critical element is the SPI or quad SPI interface. That's what talks to the Eve series of devices. Eve will handle the display, the touch and the audio. But what's important about the 90X is this super bridge can bridge your display to other interfaces. Remember, it's a window to a wider world. We can do it over Ethernet, the parallel camera interface. So if you wanted to do your smart doorbell or remote monitoring with CCTV style technology, we can grab camera data and output it on the EVE solution through this MCU. We can talk over Ethernet if we are in the scenario where we're in the retail outlet and we're placing the order front of house to be processed in the back warehouse. That's what the SuperBridge of FT90X series can offer. We have a module, the MM900EV module. So again, not only does FTDI offer silicon, it offers development platforms and application solutions. The MM900EV is feature-rich, brings out all the FT900 chip elements. We've got the camera, the Ethernet, USB as well. We can't forget FTDI's heritage. So we've got onboard high-speed host and high-speed device. With, again, this Micromatch connector, which will be plugging into a new FT800 module. So this is the ME800 series of modules will plug directly with these MM900 EV modules. Again, although it's FTDI's proprietary processor, this will come with a full library of sample applications supporting this microcontroller talking to our EVE series of devices. Quick block diagram of the FT900 perhaps explains what you get most succinctly. You can see we've got a 32-bit core, 256K of flash. That's where your program memory is stored, and at runtime we copy this into our program SRAM. This allows us to operate at 0 wait states with a 100 MHz core clock. There's an additional 64K of data RAM that will be used during the runtime of your application. And then, as we say, this is a super bridge. We can match any interface to any other interface. We have the SPI, which is down here in the quad SPI, which is going to talk, sorry, the master, which is going to talk to the EVE chip. We've got, for example, the camera, if we're grabbing data. We've got the Ethernet, we've got the USB, we've also got an SD card. So it's similar to the Plus module, the VM800P. We can recreate that with the FT900 microcontroller. We could even have, if your solution is battery operated, our USB ports support battery charge detection to facilitate fast charging of a battery on your solution. In addition to these high-speed interfaces, we have all your standard I2C. The I2S is actually very good for audio. You can connect that to an audio codec, decode MP3, that type of audio format of file. So the basic features then, 32-bit RISC core, true 0 wait state operation up to 100 MHz. Your program memory, your flash, 256K is on board. We have timers for Watchdog and a real-time clock. The debugger, so we have a one-wire debugger which allows you to load firmware into the chip, or you can single step through your code through this debugger interface talking to our Eclipse tool plugin. We have a DFU bootloader. DFU, it means device firmware update. So as an alternative to updating your firmware over the debugger, you can update your firmware on chip over USB. This would be ideal for field technicians, perhaps updating products once they are out with the customer. The basic 900 is a 100-pin solution, but again we have other packages which I'll explain on the next slide. So here we have the 900, 901, 902 and 903. These are all 100-pin packages, either QFN or LQFP. The FT900 includes all the features, while the other three optionally take out CAN, Ethernet or both. By taking out CAN we can reduce cost because we have no license fee for the CAN element. By taking away Ethernet we can reduce the power consumption of the device, as it has its own dedicated power supply, so we switch that off. And then the bottom 4 devices, the 905, 6, 7 and 8, remove the high pin count elements, the camera, the SD card and the I2S, to give you either a 76 pin QFN or 80 pin LQFP option. This leads us to application areas with data acquisition with storage, so you can capture your data, store it to either USB memory or SD card memory. Data acquisition and remotely log it over Ethernet. CAN communication, so we can be like an industrial control solution. Data management. Room control system, so this is your smart home, your iHome, which is the FT90X and FT801 put together. I see some questions have come in just as I move to what is essentially the last key slide. If you just bear with me while I bring up some of these questions. Someone is asking if the development tools are Windows only or if we have an OS X, so a Macintosh type option. At this time, the tools are Windows based. We use Eclipse as a basic IDE. This is a free IDE that you can download from the internet, and we have put plugins to support our debugger. But the chip uses a basic GCC compiler, so it's relatively standard coding, C coding through this development environment. And Stephen, is there anything you would like to add at this time?
There was another question. Can I start using the Screen Editor and Screen Designer software without hardware?
Yes, the Screen Editor and Screen Designer are designed as standalone products, so you can develop on your PC without any EVE hardware as such, and it gives you the tools to understand the contents of a display list. The whole purpose of these tools is to abstract development away from the microcontroller. All the microcontroller really needs to understand is, how do I talk SPI? How do I read and write over SPI? These tools are focused on what am I sending over SPI, and so you do not need the tools, do not need the hardware for that.
So people can start downloading that from the FTDI chip website today, right?
They certainly can, yes, on our support and utilities page.
Okay. There was one last one as well. Let me just... I am a German customer and I would like to use German characters in my text. Is that possible?
So yes, we have 15 embedded fonts already based around the English language or the English alphabet. But for customers who want German or Chinese or Arabic languages, we have a tool which will allow you to take a TrueType font, which are files you can get freely off the internet. They come with Windows in a lot of cases, and we convert this TrueType font to a format that EVE can recognize. So you would do your transfer, and then you would store your dedicated font in the object RAM on the chip, and you would just treat it like a normal bitmap essentially.
Okay, that seems to be all then. So thank you very much, Gordon, for that. So as Gordon mentioned, we're a global company with global offices in various countries there. We have a UK-based technical support helpline, which is the email address there, support1@ftdichip.com. But of course, we have regional support as well, if necessary. You can purchase all the boards and IC that has been mentioned in this presentation from the Farnell website. So that's www.farnell.com. And thank you very much for your attention and your participation today. We look forward to working with you on your next EVE designs. Over back to David.
All right, thank you so much, and thank you FTDI for a great webinar, and for those of you who attended it. So if you're interested in more webinars like this, you can check it out. More webinars, we usually do them once a week, if not more, at www.element14.com/webinars, and a recording of this webinar will be made available probably in the next 24 hours or so on the event page in which you registered for the event. So with all that being said, we'll say thank you again to Gordon and to Stephen for a wonderful presentation, and we will see you next time. Thanks, everyone.
Thank you. Bye-bye.
Thank you. Bye-bye.